So what I wanted to do today with you was actually to share with you some of the work we're doing in basically in two places at MIT, at the SENSEABLE City Lab. It's a research group with around 30 people in Boston and also a new lab in Singapore. And also in our design office, the projects that go more into architecture, planning, building a new city or objects, which we do actually in Italy, in the UK, and in the US. Now, can we have the lights off a little bit? I think we'll see the slides better. So, you know, I wanted to start by sharing with you this picture. I'm Italian. Everybody in Italy grows up with a picture like this in their bedroom. But the reason I'm sharing this with you is actually that something interesting happened in Formula One over the past 15, 20 years. Now, 15, 20 years ago, if you wanted to win a Formula One race, you need a good car and a good driver. You needed solid physical things. Today, actually, if you want to win a race, you also need something like this. A system that's made of thousands and thousands of sensors onto the car, collecting information in real time, sending that information to those computers where it's analyzed, it's processed, and decisions are made in real time. In other terms, that's what engineers would call the real-time control system, which is a system made of a sensing component and an actuating component. And sensing and actuating is really what every dynamic system does and what every living system does. When we meet each other, we sense each other, we shake hands, we collect information from each other, and then we respond to that information. Now, the amazing thing we believe is that today our cities are starting to behave a little bit like that Formula One racing car. Our cities are being covered layer with many, many different types of networks, and because of that, the way we can understand them, the way we can respond to them, design them, and ultimately live in them is actually radically changing. And let me make an example of one of these networks that now allows us to understand a lot of things about our cities. Well, it's the cell phone network. Now, it's quite surprising to think about that today, 30 years ago, we still didn't have cell phone connections. And, the first one is actually 1979. It's the first one in Japan by NTT. And then it takes almost 20 years to get to 1 billion, and then it has been growing exponentially since then. Now, you may say there's 7 billion people on the planet. You might say, how much more can this grow? Well, look at the projections by Ericsson, the most recent projections. They say we're here and we'll get to 50 billion by 2020. And how could it be? It's not that each of us will have like 7 iPhones in our pockets, but it is that actually we started looking at connecting people to people, and more we're connecting people to data, and then people to machine to data, and machine to machine. So everything getting connected to everything else. Almost as every atom out there were becoming both a sensor and an actuator. Now, you might ask, so where is all of this leading us then? And we think the consequences of this are quite exciting. There was an exhibition at MoMA, the Museum of Modern Art, just a few months ago. We were part of it. And the exhibition curated by Paolo Antonelli was titled Talk to Me. The idea that because of all of this, our cities, our objects, our homes are starting to talk back to us. They can engage with us in a much more dynamic relationship. And, if you look at architecture has been trying to do this in many different ways, trying to create living buildings that would, try to be alive. But if you look at this, that's a beautiful building from the Baroque time. There's kind of a tragedy. It was trying to capture movement and life, but actually it was dead. It was made of stone. It was made of, it was frozen in a certain sense. And today, for the first time, we believe we can actually use technology to create really a dynamic relationship between us, our cities, our buildings, our objects. And what I will do today is actually share with you some of the projects we are doing in this space, divided into two components, the sensing component and the actuating component. Now, on the sensing side, first project I want to share with you is this. It's called TrashTrack. If you look at that computer, you know everything about the computer. Every chip, you know how it was produced, how it moved on the planet, how it became that machine. It's what you see here. However, a few years from now, when you throw away that computer, you know very little about it. And actually, sometimes it ends up where it shouldn't end up. Like, a lot of e-waste, electronic waste from the United States actually is shipped illegally from Europe as well, sometimes to Africa. So our idea was, what if we can actually develop a little tag, put a tag on trash, and start looking at what happens to trash when we throw it away. Here's the first deployment we did. This was in Seattle. We invited leaders. So we invited 500 volunteers, and they came with 3,000 pieces of trash, every possible thing. And then after having tagged all of that, we started following it. Here you can see the day of deployment. In Seattle, after a few days, you see the main landfills next to Seattle. But then a big surprise, actually, how far something started traveling. Nobody expected it. Sometimes in crazy ways, you see the trace that goes all the way from Seattle to Chicago down to California for thousands and thousands of kilometers. Still moving after a month, 2 months. So what can you learn from this? Well, the first thing you can learn, if you are an engineer, you can think about get all this information and actually how this information can tell you a lot about how the system could be more optimized, how you can save energy, say, in actually redesigning the system to move around waste. To think about how much wasted energy in all those traces that sometimes were going randomly and for many more kilometers than what was actually needed. Now, the other thing that we thought was very interesting, we discovered is that if you get this data and actually share it with people, with all of us, then we can promote behavioral change. So basically the idea that we got more information about our cities, about our environment, and because of that, we can actually respond and make different decisions. One example is somebody who came to us after the project and said, I used to drink water in plastic bottles every day. And then put the bottles outside my home and forget about them. But actually now I can't forget about them anymore. I know they just go a few miles from home, go to a landfill, stay there forever. And because of that, I actually changed my behavior and stopped drinking water in plastic bottles. So that's really this big important field of behavioral change. Now the third thing we discovered was actually completely unexpected. And that happened just a few months ago. That's when a burglar came to our lab at MIT and stole a lot of things, including some of the tags that tell you where they go. And here is what happened. All right. Well, this was just one example about sensing. About how today we can actually collect information from our cities in a different way, from our cities, homes, and objects. There's many, many more examples. Just because of the lack of time, I'll share just this. But on our site, you can see how you can experiment with networks, data coming from user-generated content. All this incredible amount of information we produce in cities. And just to tell you about how much information we produce today, think that if you take all what was produced by humanity from the beginning till 2003, Well, now the same amount of data we produce every couple of days. So that's really to give you a sense of how much information we produce. Now, at this point, however, I want to share with you the other side, which is response to the data. So not the sensing, but the actuating, how we can know more about our environment and respond to it. Sometimes this is about architecture. In this case, that's a project we did at the center of the World Expo in 2008 in Zaragoza. It was just before Shanghai. And the theme of the expo was water. And the mayor came to us asking, how could we use water, a beautiful ingredient of architecture and planning in the past, how can we use it in a different way? And one idea was, imagine you have a pipe, and you have many little valves opening and closing on the pipe. And then, you can create almost like a living material made of water, where you can write on the water, you can show images, text, patterns, or, if you approach it, it can open up to let you in. The mayor liked the idea, so we got the commission to design the building at the entrance of the expo. The name of the building was Digital Water Pavilion. The whole building is made of water, as you see. And then there's no doors or windows, but when you approach it, it opens up to let you in. When you're inside, all of the walls expand and shrink based on how many people you have. It becomes like a fluid, dynamic architecture. And then when you go on the top is also covered with a thin layer of water. Then, if there's too much wind, you can actually lower the roof to minimize splashing. Or at the end of the day, you can actually close the building and the whole architecture disappears. Hopefully without anybody underneath. We have sensors for that as well. So you can see here that was before the opening. This guy was just there with a trolley, was stopping by and stayed there for like 15 minutes trying to understand what the hell was happening there. Here it was myself trying not to get wet and testing the system that actually opens and closes. Here it was actually using digital projections on the top of the water. So you got the pixels made of water, but also pixels made of light on the top of it. And I should tell you now what happened one night when actually all of the sensors that detect people when they approach stopped working. So, the building is made of all this complex digital system. All of it is connected to a computer. The computer crashed. And so the building would keep on doing its own crazy things like cuts and holes and writing, but wouldn't respond to people anymore. So that night we were terrified because we wouldn't know what would happen. But actually that night was one of the most fun nights. That night thousands of kids from all of the city actually came to the pavilion to engage with the pavilion in a different way. Not anymore a pavilion that opens up to let you in, but a pavilion like this. And for us that was a surprise, because in a nice surprise, because as architects, engineers, we always think that we know how people will use the things we design, but actually reality, and especially human reality, is always a surprise. Now, I wanted to finish with one final project in the last remaining few minutes. It's something we did with the city of Copenhagen. The mayor came to us and with a very precise question, how could all of these technologies help us, for instance, with traffic? And the amazing thing is that traffic in Copenhagen means bikes. Copenhagen is a city where we had a lot of cars in the past, and now it's very cool to go by bike. Actually, 30 to 50% of all trips every day happen by bicycle. And this is the landscape that you see in the city. So we started working with bicycles and came up with the following idea.
Welcome to the Copenhagen Wheel. The wheel that turns your ordinary bike into a smart electric hybrid. Quickly and easily, with no additional batteries or wires. The Copenhagen Wheel allows you to capture the energy dissipated while braking and cycling, and save it for when you need a bit of a boost. Controlled through your smartphone, the Copenhagen Wheel becomes a natural extension of your everyday life. The Copenhagen Wheel is your personal trainer, sensing your effort level and providing you with real-time feedback about your fitness and exercise goals. The Copenhagen Wheel also enhances your experience in the city. It connects you with things a cyclist wants to know: upcoming traffic congestion, road conditions, and pollution levels. Choose to keep your data Or share it with your friends and other cyclists through social networks like Facebook. As you ride, you also collect green miles. It's similar to a frequent flyer program, but good for the environment. Elegant, responsive, smart. A new mode of transport for a rapidly changing world. So turn on your life and turn on the city. The Copenhagen Wheel.
Oops. So, and what I wanted to share with you is, this was the initial idea, but I want to share with you how the idea developed. Actually, the idea now became a startup, so it's going to be commercial soon. We got venture capital funds, and Asaf Biderman, who's the associate director of the lab, is the guy who's running it. But I want to share with you how the idea actually developed from an initial idea, a workshop with a number of students at MIT, and thinking about biking and how different apps could help biking. And one of these ideas was, this wheel. In the beginning, was almost nothing. There wasn't much thinking or technical thinking behind, but it actually a wheel that could allow you to do things, to save your energy and give it back to you when you need it. Then, following the student workshop, then, we say, well, when you got an idea, you don't know if it works or not. The best thing you can do is actually, let's try it out. Let's see what happens. So here was the first prototype. You can see just the first sketch, putting together different pieces, combining the batteries, the motor, mounting all of it, and the first wheel, not looking too good, but actually it was working. And here was the test at MIT, and then in Copenhagen with the mayor. The mayor actually liked it, so, well, like you do usually in these cases, back to the drawing board. Let's go back and try actually to see, really start from scratch and see how we can redesign it better. Defining the brief, what we wanted to do, so something, as you saw in the video, that can be easily retrofitted to any bicycle, can have regenerative braking. You brake and you get your energy back. Intelligent locking, so that actually the bike knows when you get there. If not, it will not unlock. And if somebody steals it, then, in the worst case, they will charge your batteries, but you will find it. Electric motor, the sensors, and really having the bike almost become like your personal trainer. Here you can see the new design, putting all the pieces together, choosing the motor, the electronics, combining them. Once we had everything inside, then we had to decide how to connect the hub actually with the rim, with the wheel. And this was the initial sketch, pretty bad, as you can see. Then somebody came up with this idea that's actually cooler, but it doesn't work. If you look at this, the torque from the center actually doesn't get connected doesn't get transferred to the outside. So it's very difficult from a structural point of view to move the torque from the inside to the rim. And then, we came up with this concept that we thought was cool, the spokes that actually start from the rim and just simply touch the hub and curve 180 degrees and then go back. But, some people thought it would work, some people thought it wouldn't work. And again, when you got a if in doubt, let's try it out. So that was the first model, made of just laser cut, made of pieces of cardboard. This was done using a 3D printer. These machines that you're familiar with, now you can not only print a piece of paper, you can print an object, and it can be quite strong. So they're mounting all the spokes on it. He was very skeptical, as you can tell. But actually, this was working. So this became the way to spoke the wheel and to do it. And then, there was all the control through the smartphone, all the different pieces, being able to add the sensors, and not like this, but more little sensor that would tell you CO, NOx, and so on. And just a few bikes in Copenhagen can actually tell you a lot. As you see here, the city gets covered almost immediately by the data collected from the bikes. And then from there, really building a few prototypes to show to the mayor at the big exhibition in Copenhagen, mounting them, programming them, and then shipping them and presenting them. Here is the mayor of Copenhagen. And here in the next slide, you see actually the mayor of Copenhagen and mayor of Toronto trying it out for the first time. But I want to share this with you for one reason, that actually the way that we can design in the city is changing a lot when we look at technology, space, and the physical and the digital coming together. First of all, it's much more collaborative. You really need many people together working on the city. And then also you need many disciplines, going from the traditional disciplines like design and planning to people doing, say, electrical engineering, computer science, or even mathematics and physics, to people doing doing social sciences and helping much more with the interface to human. And here is the video of the two mayors actually trying the wheel for the first time.
Run away, run away, run away. Oh, I felt it. Excellent. This bike is fantastic. It's incredible. It takes no effort. You see my bike? You start pedaling and the motor takes over. And then it will tell you the air quality, the temperature. Incredible cars. It's amazing to see an idea come to fruition like that.
All right. And I'll stop it here, and we'll have a discussion later. Thank you.